Okay, today we're doing page 30 in your math journal. So make sure you label this one page 30 just on the back side of 29. We're going to be talking about powers of 10. This should be pretty easy, and I think most of you understand the idea behind powers of 10, but we're just going to do a couple examples to make sure that you are ready for what we're going to do tomorrow. Okay, when you multiply by 10, let's just do some examples here. So I want you to take and do 6 times 1. What do you get when you get 6 times 1? 6. All right. Now the next power of 10 would be 6 times 10. And what do we get? 60. 6 times 100 would be the next power of 10, meaning 10 times 10. And we get 600. 6 times 1,000. And we get 6,000. Well, what I know a lot of you are thinking is, yeah, you just put a 0 on the end when you're timesing by stuff like this. However, you need to make sure that you understand the idea of what's happening. It's not simply adding a 0. It's actually shifting the 6 in its place value. Notice how here it's in the ones place. Now the 6 is in the tens place, the hundreds place, the thousands place. Well, when you're doing that with decimal numbers, the same exact thing happens. As you times by powers of 10, the place values shift up. So where's the decimal on this 6? Right here. On the 60, right here. On the 600, right here. And on the 6,000, right here. So then what do you think happens when you take something like this? Say 1.74 and you times it by 10. Or let's do times by 1. What happens? It stays exactly the same. The decimal is in the exact same place. So what happens when you do 1.74 and you times it by 10? Well, now everything is 10 times greater, or all of your place values shift up to the next place value. So that is worth 17.4. Now notice what happened to your decimal. It actually moved back to make this a bigger number. So what happens when we do 1.74 times 100, or 10 to the second power? That means that it's going to shift 2 times. So this is actually 174. Okay, if we do it with 1,000, then we have 1.74 times 1,000. And all of our units are going to shift up one more place value. But we've run out of things written here. But what's the digit just past this 4? It's actually a 0. So it would be 1,740. Now, where's the decimal on this number? Right here. Where's the decimal on this one? Right here. So notice this moved none. This didn't move at all from here to here. Here, times by 10, it moved one place value. By 100, it moved 2 place values. Here, it moved 3 place values. So when you are multiplying by powers of 10, it moves the decimal up if it's a bigger one. Now, there's something interesting about dividing by 10. Okay, let's try something similar here. So if it moves the decimal up when you're timesing by a power of 10, what happens when you divide it by 10? So if I take 6 and I actually divide it by 10 this time. If I take 6 and divide it by 10, that means 6 tenths, which written as a decimal is actually 0.6. So what happens if I divide that number by 100? I'm actually going to end up with 0.06. If I divide by 1,000, are you seeing a pattern happening here? Notice here, where's my decimal on the 6? It would be right here. But when I divide by 10, it moved the opposite direction as did up here. So it actually moved back and made it a smaller number. Here, it moved 2 times. So what do you think is going to happen here? It's going to move back 3 times. So this would be 0.06. 0.006. So if that's the case, what would happen with our example of 1.74? So let's do 1.74, only this time we're going to divide by 10. Shift our decimal back 1, make it a smaller number, be 0.174. If we do that with divide by 100, we need to move the place value back 2 times now. So that would be 0.0174. If we do it by 1,000, we shift it back 3 places. So we would have 0.00174. Now see how our decimal has moved 3 places here? 1, 2, 3. Okay, so when you are dividing by 10, it's going the opposite direction as when you're timesing by 10. So what I want you to remember is when multiplying by powers of 10, meaning 10, 100, 1,000, 10,000, etc. The decimal moves to the, which direction does it move? The decimal moved to the right. To make the number larger. But the digits stay the same. Okay, when dividing by powers of 10, so skip one line. When dividing by powers of 10, the decimal moves to the left. To make the number smaller. But the digits stay the same. That's why we love multiplying by tens, hundreds, and thousands. It's super easy for us to do in our head. So, but the digits stay the same. Okay, that will help us out for tomorrow's lesson.